Hello everyone, I'm Ho Junlok from Group 2 and now I will present the final report for our project, which is Pedestrian Road Crossing Traffic Controller. So these are all of my teammates, so let's proceed to the first part, which is the introduction part, which introduce the whole project, that what are we doing. Next we'll go to the block diagram part. So in this project there consists an input, which is the push button, and the middle one is the ARM microcontroller which we use, which is STM32L4, and also three output. First one is the 7 segment display, and the other two is the LEDs, red and green. Next, this one is the circuit schematic diagram for our project. So here, this one is the push button, this is the LED, the middle block is the microcontroller, and this one is the 7 segment display. This circuit schematic diagram clearly shows all the ports and pins we are using for this project. So this is the hardware setup. This one is the microcontroller, the middle one is the 7 segment display, and these two are the LEDs. So we proceed to a flowchart part. This is the main program flowchart, where we start here. Then these are the ports definition. Then here is to check whether is the button pressed. If no, it will turn the red light on and the green light off. If yes, it will delay first, then it will check again. If yes again, then it will turn the green light on, then the red light off. Then it will proceed to the subroutine, which is for the 7 segment display, and this subroutine call number. Yeah, and this is the subroutine flowchart for the 7 segment display.
First, we start to declare our STM32 L432 library. Then we declare a function, which is delay ms, and then we start with our main program. So we start with disable IRQ globally. Then we initialize the GPIO configuration. We enable the GPIO-A and GPIO-B clocks by using this AHP2ENR register. Then we reset the model by using mode register, and we set the PS0 to PS6 as our output for 7 segment display. And then we also reset the model for PB0, PB3, and PB4. And then we set PB4 as input, and we set PB0 and PB3 as output for LED. Then we set the port A as push pull and port PB0 and PB3 as push pull also by using O type register. Then we enable the pull out resistor at PB4 by using pull out pull down resistor. So this make our system become a active low system. So we go to the while loop. For this while one, it will ensure that our system, it will continuously checking the button is it pressed or not. So the system, it will continuously repeated. Then if our button is pressed, the value inside here is equal to 0. If yes, it will have a delay of the 50 millisecond. Then it will check again if the button is still pressed after the debounce. If yes, the green LED it will on and the red LED will off. Then it will start counting down from 9 to 0. So by using this for loop, so if the condition is correct, then it will go to the switch case and show out and light out on the 7 segment display for the corresponding number for our number value. So it will after the number, it will not greater or equal to 0, then it will out of the for loop. So for every number, it will delay for 1 second for the counting down. And then yeah, that's all. After this for loop, the counting down is end, then the operation is also end. So what if the button is not pressed? So if the value inside here is equal to 1, then the button is not pressed. So it will go to the else. We will turn off the 7 segment display, and the red LED will on and the green LED will be off. So lastly, we have a white delay ms function. This is a declare for our function delay ms function. Yeah, so it will delay to use inside our coding. So let us check our program can run or not. Okay. start to run. Yeah, so you can see there's no error and our coding is functions successfully. Yeah, that's all. Thank you.